Now we are going to the next the second topic for 3.3, that is dependent samples. For this part, the parameter used denoted by mu d. Okay, and as usual, okay, there are three types of tests: two-tailed test, right-tailed test, and left-tailed test. And again, mu naught in this case is known as hypothesized mean. Okay, which can take any real value. For the dependent samples, usually we will deal with population variance unknown and sample size small. So that's why, okay, the test statistic that we always consider, that is the test as given on your slide. Okay, for the t-test, we can compare with the t critical value with a degrees of freedom n minus 1. To understand better for the concept of dependent sample, so now we look at example 3.5. Okay, so when we look at the question given, okay, is it wise for the factory management to install the new gadget? So this is very general statement. So to consider which parameter that we need to use, so we can look at the data given. Okay, the data given here, that is about the number of bacteria floating. So the most suitable parameter that we need to consider, that is mu. So now for this case, parameter that we need to consider is mu. So we have two dataset B, dataset B for before, dataset A for after. Then means that for this case, this is under difference between two means. For the case of difference between two means, we need to be careful, okay, because this is either this is under independent sample or dependent sample. Okay, dependent is mu d. We can identify the theta, the suitable theta here, by looking at the data given. We can see that the data set of before and after is dependent to each other, or there is a relationship between data before and after here, because the subject here is the factory is the same. So for this case, this is under mu d. So we write here d here. So for d, okay, for d here, this is equals to a difference between data before and data after. So there are two versions for d. Okay, the first version, if you want to choose B minus A, okay, B minus A or A minus B, remember that we want to look for the D that wise, okay, wise to install. So wise to install, when we want to compare data B and data A, so look at the variable here. The data here is about the number of bacteria floating. So it is wise to install the gadget instead to show that the gadget is efficient. Okay, so for this case, D here can be B greater than A, means that, or we also can write A for the case of A less than B. Actually, B greater than A, this is the same as A less than B. So From here we can get b minus a greater than 0, and for this version we can get a minus b less than 0. So there are two versions of D that you can choose. Okay, both versions are accepted. Okay, either b minus a greater than 0 or a minus b less than 0. So when we want to construct the statement for mu D, you can choose either one. For the first version, for example, you want to choose for b minus a. So this is mu D greater than 0, where D here is equals to b minus a. Okay. The second version, okay, this is the claim. Claim that is wise to install the gadget. The second version, that is mu D, okay, less than 0, where D here, this is also the claim that it is wise to install the gadget. So D here, for this case, D here is equals to a minus b. So you have to claim, but the claim here is the same. Both claims show us that it is wise to install the gadget. So now let's say we want to choose the first version. Okay, when we want to choose the first version, don't worry, actually both versions of claim will go to the same result and same conclusion. So let's say we want to choose the first version. Okay, so this version. Okay, so now when we want to choose this version, okay, this is greater than, means that the claim here is under, okay, the claim here, step 1, the claim here is under hash 1, okay, because unequal sign here, so this is will be hash 1. Okay, and this is since this is h1, so we can construct hy for step 2 here. Okay, we get the difference data between data before and after as shown here. Okay, as shown here. So from this difference data, we, by using calculator, we can get x bar d and SD. Okay, after that, apply the formula for the t-test, because this case is mu d, so for our course we only consider for the case of population variance unknown and sample size small. Okay, then simplify the answer at 4 decimal places, so complete step 2. Go to step 3. For the step 3, we want to identify the rejection region and critical value. So the test use is t-test. So we need to plot a t distribution as shown here. Okay, the t distribution. So the next step is to identify the rejection region. We can look at the inequality used in H1, that is greater than. Greater than meaning that the rejection region lies on the right tail of the distribution. Right tail. So since this is lies on the right tail, the rejection region lies on the right tail of the t distribution, means that this is under right tail test. Okay, so no need to divide our alpha by 2. After that, get the critical value here. Okay, this is t 0.05 with a decrease of freedom 6. Okay, so by using statistical table, we can get the value. So once we can get rejection region and critical value, so complete step 3. So now go to step 4. Step 4, that is about decision on HNA. So as usual, we compare test statistic in step 2 to the critical value in step 3. Okay, when we compare these two values, then we can see that t-test greater than, meaning this is lies on this region. So since this is lies on the rejection region, so that's why the decision here is we reject HNA. Okay, we reject HNA, so complete step 4. Go to step 5. Step 5, we reject HNA. Okay, meaning that we accept H1. So H1, to relate with the claim step 5, we want to draw a conclusion that relate with the claim. We can see that we support the claim. So support the claim means that at 5% level of significance, it's wise to install the new gadget.